In the first set of problems, we are going to draw an angle in standard position. So an angle in standard position is where you have the center, like this is the rectangular coordinate system, and you're having an angle which has its initial side on the positive x-axis. The vertex is at the origin, and then you have the terminal side of the angle. Now, when the angle is positive, that means you are going in the counterclockwise direction. So you're starting with this initial side, and then you're going to move to 30 degrees like so, and then you end here. This angle is 30 degrees. It is positive and it is going counterclockwise. Then 135 degrees. So 135 degrees is going to go, so 135 is 90 plus 45. So this angle is going to travel till 90 and then go another 45 degrees, which puts it in the second quadrant, and that is 135 degrees. Then the next one is 450. So for 450, let us see what 450 is going to look like for us. So this is question number 15, 450 degrees. Now 450 degrees it is still going to start on this initial side. Now this angle has traveled one full revolution and it has hit 360. But 360 is still less than 450. Now, how much less exactly is it? It is 90 degrees less, right? So that means this angle has to travel another 90 degrees and then it reaches 450 degrees. Okay. So the next angle that we have is in the radian measure. So this is question number 17, and we have 3 pi over 4. So you can keep this in the radian measure. You don't have to convert it into a degree angle measure. So let's see how you will do it if it was still in the radian. So the first thing that you probably will have to keep in mind is the same angle, right? This is still a positive angle, so it is still going to go counterclockwise. Now it is starting at 0 radian, and then when it hits here, it is going to be pi over 2 radian, and then this is going to be pi, and then this is 3 pi over 2 radians, and then it is going to go back to 2 pi, right? But my denominator is over 4. So I want to convert everything to a denominator of 4. So when I do that, how is this going to look like? 0 is still 0, nothing changes. But pi over 2 can be written as 2 pi over 4. Pi can be written as 4 pi over 4. 3 pi over 2 can be written as 6 pi over 4. And 2 pi can be written as 8 pi over 4. So when you do this, it's very easy to see that 3 pi over 4 is between 2 pi over 4 and 4 pi over 4. It is right in between both of them. So my angle is now going to be right in the middle here, and this is 3 pi over 4 radian measure. Okay. So the next angle that I have is a negative angle, negative pi over 6. So because it is a negative angle, I know that I have to travel in the clockwise direction now. So this is 19 and my angle is negative pi over 6. So again, what I'm going to do is I'm going to start with this initial side, but this time I'm going to travel in this direction. Okay. So again, because I'm traveling in this direction, let's see how we are going to mark these angles. So this angle is 0 now, right? And then this would be pi over 2, negative pi over 2, I mean. And then this is negative pi, negative 3 pi over 2, and then it's going to come to negative 2 pi. However, my denominator is pi over 6, isn't it? So that means the 0 can remain as 0. And if I convert this is negative 3 pi over 6 because 1/2 is the same as negative 3/6. And then this will be negative 6 pi over 6. And then this can be negative 9 pi over 6, and then negative 2 pi can be negative 12 pi over 6. Now, obviously, I can see that negative pi over 6 is between 0 and negative 3 pi over 6. Well, where exactly? Probably 1/3 of it. So that means it's right over here. And so this angle is my negative pi over 6. Okay. Okay, that takes me to 21. So I'm going to find room for 21 now. So let me put 21 right here. So 21 is 16 pi over 3. Okay. So now let's do this the same way that we did before. This is a positive angle. So I'm going to start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is one revolution. Now my denominator that I want is over 3, right? Now that's a little bit tricky, right? Because over 3, then I have to probably it might be a better idea if I convert it into an even. So what I would say is 16 pi over 3 can be converted to 32 pi over 6 if you want, right? So that you can see where it is going to be, because it's not possible for me to convert a half like to a 1/3, right? Instead, I can convert it to over 6 pretty easily. So this over 6 would be 3 pi over 6. This would be 2 pi, sorry, 6 pi over 6. I'll show you one more method of doing this, but let's keep it this way for now. 9 pi over 6, 12 pi over 6. Now, we have 32 pi over 6. So we are nowhere close. We are only 12 pi. So we completed one revolution, and then we have 12 pi over 6. Now let's complete one more revolution that will take me to 24 pi over 6, correct? Not 24 pi over 2 pi, and this is 4 pi. Yeah, 24 pi over 6. So 24 pi over 6, and then I go here, I add another 6 to it. So this is 30 pi over 6. Do you get the idea? So 30 pi over 6 is still less than 32 pi over 6. So I have to travel another 2 pi over 6. Now, if you go here, what will happen? See, I'm adding. So this is 30 pi over 6. So previously, we missed one here. So we have 12 pi over 6, 15 pi over 6, right? So we were adding 3 over 6. Okay, so 15 pi over 6. And then we had here 15 plus 3 is 18 pi over 6. And then we came here to 21 pi over 6. And then we went to 24. Then we went to 27. And then we went to 30. And then we are here for 33 pi over 6. So 33 pi over 6 and 32 pi over 6 is less than that. So that means our angle is going to be here, closer to the y-axis, right? So this angle is 32 pi over 6. Now, this is one way of doing this. What is the other way in which we could do 16 pi over 3? Let's see. So this is still question number 21. I'm still doing 16 pi over 3, right? So how am I going to do this? So another idea that you can have is, what is 16 over 3? I can rewrite it as a mixed number, right? So 3 goes into 16 5 times and then leaves a remainder of 1. So 16 is 5 and 1/3. Okay. Now, if you go with this, what you're going to know is, so it's 5 and 1/3 of a pi, right? So this is 2 pi, this is 2, this is 4, this is 5, and then another 1/3. So this is one thing to keep in mind. 1/3 of a pi, not 1/3 of a quadrant, okay? So one thing to keep in mind is this. Whenever you have angle measures which have a denominator of 3, those angles are going to be closer to the y-axis. So if you have, say, 5 pi over 3, 4 pi over 3, 2 pi over 3, those angle measures are all going to be closer to the y, okay? So that is one thing also to keep in mind. But we are going to be visiting this more as we move along with the next set of problems. Okay, so the next set of problems, we are going to convert each angle in degrees to radians, okay? And we want to give our answer as multiples of pi. All right, so let's see. The first angle we have is 30 degrees. So here, all the questions we are converting from degrees to radians. When we do so, this is the conversion that we are going to use. We are going to take our angle written in degree measure, and then we are going to multiply it by pi over 180 to convert it into radians. So let's see question number 23. We have 30 degrees. We are going to multiply it by pi over 180. You reduce this. 30 goes into 180 actually 6 times. So you have pi over 6 as your radians measure. Then 25 is 495 degrees. So you do the same thing in here. So let's reduce this. 495 is divisible by 9. How do I know that? Because if you add all the numbers, all the digits, it is divisible by 9. Therefore, I know that the number itself is divisible by 9. So this goes into 9 20 times. This goes into 9 55 times. Now this goes into 5 4 times. This goes into 5 11 times. Therefore, my answer is 11 pi over 4 radian measure. So you can put radians right next to it. Then 27 is negative 60 degrees. So when you're converting a negative angle, don't do anything to convert it into a positive angle or anything like that. Keep it as a negative angle and just reduce it. This goes 3 times. Therefore, negative pi over 3 is your answer. So 29 is 540 degrees. Do the same thing, pi over 180. Now this goes 3 times, right? 18 times 3 is 54. So this is going to be 3 pi radians. And then I have 31 is negative 240. Then I do the same thing. It goes into 63 times, goes into 64 times. So I have negative 4 pi over 3 radians, right? And then finally, I have negative 33 degrees. I know that this is negative pi over 2. I just write the answer. Okay. In my next set of problems, I'm going to convert each angle, which is already given in a radian measure, into degrees. So to do so, if I'm given in the radians and I want to convert it into degrees, then I multiply it by 180 over pi. So let's take my first question. I have pi over 3. I multiply it by 180 over pi. The pi and the pi should get cancelled. And then you simplify this. 3 goes into 180 60 times. So my answer is 60 degrees. Then I have negative 13 pi over 6. I do the same thing. Multiply 180 over pi. Pi and pi gets cancelled. This goes 30 times. 30 times 13 is negative 390 degrees. 39, 9 pi over 2, multiply by 180 over pi. Pi and pi goes away. Then 2 goes into 180 90 times. So this will be 810 degrees. 41, I have 3 pi over 20, multiply 180 over pi, goes 9 times. So this is 27 degrees. Okay. 43, negative pi over 2, multiply 180 over pi, goes away. I have negative 90 degrees. 45, negative 17 pi over 15. I divide this. 15 goes into this how many times? 12 times, right? and then multiply 12 times 17. 14, 2, 3, 7, 1, 4, 204, negative 204 degrees. Okay. And that's it. And that's